right, friends, it's a great day to be learning math, and why not learn simplifying radicals with variables? Okay, so before I get into this, I actually want to review the idea of how do we simplify just with like rational exponents. So this is a topic that I covered in a previous video, but it's going to be a very helpful idea here. So just to remind you of how this works, so I've got the square root of x to the 6. So we talked about in a previous video that with rational exponents, I could basically rewrite this as x to the 6 over 2, because this is how it works with rational exponents. So hopefully you're already familiar with this idea of how to kind of go between the two forms. If not, I strongly recommend that you start there before watching this video. Okay, so anyways, so now that I've written this as 6 over 2, I can see that this is just x to the 3rd. So this is something that we did earlier, just to remind you of like how we might do this one more time. So in this case, this would be, so the cube root of x to the 15th can be rewritten as x to the 15 over 3. So that just becomes x to the 5th. Okay, so I want to just ratchet up this idea a little bit and now have two variables. I strongly recommend that you pause the video here, just give yourself a chance to review this, and then hit play when you think you've got these two reviewed, and we'll see if you got them right. Okay, so this is going to be x to the 6 over 2 and y to the 8 over 2. Square roots have an invisible 2 here, right? So this really simplifies to x to the 3rd, y to the 4th, and this one, so I'm just going to divide everything by 4. So 12 divided by 4 is 3, and 20 divided by 4 is 5. Okay. So now we're going to take this idea, and when I say this idea, I mean this idea of taking whatever this index here and dividing the exponents, because that's what I did in this last one, right? And that's effectively what happened in all of these other examples. Now what I want to do is I want to, change the game a little and say, what do I do when I have the square root of x to the 5th? Okay, so this is actually a great moment to check your intuition if you've been playing along at home here. I would love if you just made a guess as to what you think this answer might be based off of some of the other work that we've done. So let's just play with your intuition. Hit play when you think you've got something. Write down an answer and, think about it, and then hit play when you're ready. And now I want to actually talk about like two different ways of how you can simplify this. There's two different ways to think about it. So way one, we could separate this into two separate radicals. So remember, one of the like big properties of radicals if you have the square root of a times b, this can be separated into the square root of a times the square root of b. So I'm going to take this idea and I'm going to apply it here. So what I'm going to do is I'm going to break up the square root of x to the 5th. I'm going to break this up as x to the 4th times x. So if I add the exponents back together, they get me back to 5. And then by rewriting like this, I can write this as square root of x to the 4th times square root of x. Okay, and so what does that allow me to do? Then I can use what we were just using with the rational exponent idea, right? I can effectively divide this exponent here by 2. So I get x squared times the square root of x. Okay, so this is one way that you can simplify. There is a second way to think about this. You can divide the exponents and use remainders. So what I mean is, so I have the 5 here and the 2 here. So what I'm effectively doing is I'm taking 5 divided by 2. Another way you could think about that is how many times does 2 go into 5? So 2 goes into 5 twice with a remainder of 1. So using this knowledge of division, what I can do is I can actually apply this to the square root of x to the 5th and rewrite this as x squared times the square root of x, where this 2 is the exponent on the outside and this remainder of 1, it's like an invisible 1 here, that's what goes here. Okay, so there's two different ways to think about this. Tomato, tomato, doesn't matter which way you want to think about this. I always say think about it in the way that works for you. And you've got this full explanation here, so you can always like go back and forth and try both. So let's try that idea again with the cube root of x to the 13th. So I'm just going to review both ways of how to do this for a moment, and then we'll have some more where you can kind of try them on your own. So let's go through this one together. So if I try with way 1, okay. So the thing that you've got to think about with this, and I do want you to think about this, is so what's the largest number below 13 that 3 will evenly divide? I know it's kind of a lengthy question, but what's the largest number under 13 that 3 will divide? That would be 12. So I can actually break this up, this x to the 13th, into x to the 12th times x. So 12 plus 1 will make 13. So I have to break this up in such a way that it still adds up to the original. And then I can break this up into 2 separate cube roots. And from here, so the cube root of x to the 12th will just be x to the 4th, and then I have this other cube root of x just kind of hanging out. Okay, so now, again, I want to just compare that to way 2, so 13 divided by 3. So again, maybe you should just write down for yourself. So how would I think of 13 divided by 3 with a remainder? You can pause and write that down. So this would be really 4 with a remainder of 1. So I want to just show you now how I set that up. So if I have like the cube root of x to the 13th, so what I do in my head actually is I say, okay, how many times does 3 go into 13? The second that I notice this will not evenly go into 13, what I will do is I'll put an x on the outside and an x on the inside, because I know that there's going to be a remainder, and when there's a remainder, I'm going to have a term under the radical, okay? So I set this up. I haven't done anything yet besides set it up. How many times does 3 go into 13 evenly? It goes in, now watch this, 4 times with a remainder of 1. And I don't actually need that 1, so I'm going to erase it, but in the spirit, there's a 1 here. So literally, see how it gets you to the same thing? So a lot of people like this because it's faster, but sometimes they get confused with it. So it kind of just depends on how you synthesize information. This is a really great way just to make sure that you've tied everything out. This is the faster way, but I've noticed sometimes that people can kind of trip over in their brains with it. Okay, so you know what time it is. It's time for you to try this. Why don't you pause the video here, try this whichever way you'd like, hit play when you're ready. Okay, so if I want to do this with way 1, so maybe I'll just do 1 here. So this would be the 4th root of x to the 20th and the 4th root of x squared. So that's just going to be x to the 5th and then the 4th root of x squared. And if I go the other way with this, so if I want to simplify this, so I know that 4 will not evenly go into 22. So I'm just going to set this up and then I'm going to do my division. So 4 goes into 22 evenly 5 times with the remainder of 2. Okay, so now let's make this a little harder. So now I'm going to throw a number in there with everything else. So I'm actually just going to challenge you to try this one totally on your own, and then we'll talk about different ways to do it, so you can hit play when you're ready. So one thing I've noticed is that a lot of times when I first bring up 2 different ways of how to approach this, a lot of people say they like way 2. But when we start getting into things that are more complicated, a lot of people will revert back to way 1. So I actually think it's important to kind of understand both methods, because context always really matters. And so, you know, sometimes when you add up another layer of difficulty, then you want to change up how you're approaching things. Okay, so if I go with way 1, so here's why I like way 1. So I know that for 12, I need to find the biggest square that goes into 12, which is 4. Okay, so I know I'm going to have square root of 4 and then square root of 3. Okay, now I'm going to just keep going with this. So the square root of x to the 6th, that I can break down fully. The square root of y to the 7th, I cannot, but I can break down y to the 6th, and then I'll have this remaining y. So one way that you could approach this is you can have, I like to think of this as, this is what I can take the root of, and this is what I cannot. So I'll like separate it into 2 parts. And then this becomes 2x cubed, y cubed, and then the square root of 3y. Now you can 100% use the other way to do this. the only thing that I find like can get confusing sometimes is then what do you do with this square root of 12? Because you're not dividing with the square root of 12. So you have to feel like pretty comfortable with simplifying square roots. So I know that this is going to be square root of 2 out here, square root of 3 here. And then when I think about this, okay, so let me go through the division algorithm again. So 2 will evenly go into 6. So I'm actually just going to put an x here, and I'm not going to put in a remainder. And then I'll put a y here with a remaining y here. So now I'll start my division algorithm. 2 goes into 6 3 times. 2 goes into 7 3 times with a remainder of 1. So tomato, tomato, again, totally doesn't matter. But sometimes I just find like once we start getting in with extra numbers, like some people like to revert back to this. So, you know, don't be like, oh, I can only do it this way. You know, be flexible. You know, you are learning hard things and you can think about things in more than one way, and that will make you a stronger, you know, just student. So flip back and forth. Okay, so why don't you try this one entirely on your own and hit play when you think you've got it. Okay, so just for the sake of time here now, I'm actually just going to go ahead and I'm going to use way 1, and if you used way 2, you should have gotten the same thing. Okay, so here's how it would break down in way 1. So these are the largest numbers that I can take the cube root of. So this is going to be 5. That's a terrible looking 5. 5s are always like the hardest for me to make. And then I like get flustered and then I write down the wrong thing. And you know, sometimes making these videos, it's a lot of pressure. Okay, so 3 goes into 6 twice, 3 goes into 15 5 times, and then here's my remainder. So if you did way 2, you should have gotten the same thing. Bada bing, bada boom. All right, so hopefully you're kind of feeling okay with this. Let's just do one more to check your understanding. Pause the video. Math is not a spectator sport. Hit play when you're ready. Okay, so in this case, the one thing I just want to remind you of is that you can 100% turn this into 2 radicals, which I actually think is helpful because you can take the 4th root of y to the 8th. This one's going to have some remainders. So I'm still just going to use way 1 just to show you what the largest things, words not helping, what the largest factors are that go into this. So let's see, all of this. So I can take the 4th root of y to the 8th. So this denominator is just going to be y squared. So I'll just write it as y squared. Okay, so 16 times 2 will make 32, and 16 is the largest 4th root, or the largest quartic. Quartic is the word I was looking for. I don't know why I can't think of words. Okay, so here's our setup. So in the end, my answer will be 2x times the 4th root of 2x cubed over y squared. Okay, so that kind of gives you a decent idea of how this works. You know, some people want to start, you know, and start practicing this right away. But if you feel like you need more instruction or examples, I do have other example videos on this, so feel free to check those out. And if you found this helpful, I would love it if you hit the like button or the subscribe button. And I will talk to you guys next time. Peace.